Hello again, students. In this video we're going to look at multiplying two rational expressions together. Now in the previous lesson we looked at simplifying a rational expression. Now when it started as a sum, I turned into a product by factoring both the numerator and the denominator. Factoring allowed us to cancel or divide out a common factor, which allowed us to simplify it to the expression that you see here. Now we're going to use that same process in order to find the product of two rational expressions. Here we have one fraction being multiplied times another. Well, there's three real steps that I think you need to take in order to do this. And they are factor, cancel, simplify. So it starts as a sum in the numerator of each of these fractions and the denominator of each fraction. I'm going to use factoring to turn it into a product. If I then have the combination of products in the numerator and denominator, I can cancel out any common factors and then simplify whatever expression I have left. So in order to multiply these two rational expressions together, I start by factoring each individual part of it. We'll start by factoring the numerator on the left. 3x minus 3x squared, two terms with a common factor of 3x. I'll factor out a common factor of 3x, which would leave me with 1 minus x inside of parentheses. Next, I'm going to factor the numerator of the fraction on the right. Well, x squared plus x minus 20 would factor into the two binomial factors, x plus 5 and x minus 4. The multiplication part, when I multiply two fractions, I multiply numerator times numerator. So I'm going to take 3x times 1 minus x times x plus 5 times x minus 4. And essentially, having them written next to each other implies multiplication. Now I'll do the same for the denominator. Factoring the trinomial that makes up the denominator of the left fraction, I have x plus 5 and x minus 1. And my other denominator is a simple 3 times x, which I'll write like so. Again, having them written next to each other, again, implies multiplication. Then what I'm going to do, and again, you could rewrite this separately. I'm going to move each of these expressions down here. So this is my denominator put together. Here then are the terms of my numerator, all brought down as one piece. Now I have both numerator and denominator written as a product. That being the case, I can cancel any common factors that I see. The first common factor I notice is an x plus 5. X plus 5 divided by x plus 5 is 1. I'll cancel that. The next factor I see is a 3. There's a 3 here and a 3 here. The x is separate. Again, it's 3 times x and treat it that way. But then I do notice that there is an x by himself up here and a second x down here. We'll go ahead and cancel the x's. So at the moment, we have for a numerator 1 minus x times x minus 4 divided by x minus 1. Now, most of the time that would probably be good enough. But in this case, I see that I have a 1 minus x and an x minus 1. Now, those are pretty close. Maybe if I were to manipulate one of those expressions, I could make them be a common factor. So I see that these two terms are the opposite of the two terms I see in the factor in the denominator. That being the case, I'm going to go ahead and factor out a negative 1 from this binomial. Factoring out a negative 1 would turn this positive 1 into a negative 1, and this negative x into a positive x, turning the two around and changing each of their signs. I still have the x minus 4 as the other part of my numerator. My denominator is still the x minus 1 that I had to begin with. And now, because I manipulated the 1 minus x, factored out a negative 1, I'm able to then cancel a common factor of x minus 1. This leaves me with a negative 1 times x minus 4, which I would simplify. I would probably distribute the negative 1 and make it negative x plus 4 for the final answer to that multiplication of two rational expressions. We're going to look at a second example now. In this second example, I have a fraction being multiplied by a polynomial. Now, when I look at this, I have to imagine that there is a 1 for a denominator. And again, when I multiply fractions, I multiply numerator times numerator and denominator times denominator. Well, let's try to factor and then cancel and simplify some of these things. Now I notice that x minus 4 is a binomial factor. There's nothing I can do to that. But I have x cubed plus 8 for denominator. Now this can be factored using the difference of cubes factoring pattern, which you can find back in chapter 5, our study of polynomial functions. Factoring this expression will give me x plus 2 as the binomial factor, and then x squared minus 2x plus 4 as the trinomial factor. Now if you notice, these two terms come from x cubed plus 8, so this would be my denominator. My numerator is x minus 4, which I had from the first numerator, and x squared minus 2x plus 4, which can't be factored, but if you'll notice, is exactly the same as the trinomial factor that made up our difference of cubes factoring pattern. So I don't need to factor this any further. I notice that there's a common factor. Even if it is a common trinomial factor, I can go ahead and cancel x squared minus 2x plus 4. The simplifying part means I write whatever I have left as in simplest terms possible. So that'd be the x minus 4 term in the numerator and x plus 2 in the denominator. Again, I can't cancel the x's because, or the 4 over 2, because these are both part of a sum and not a product. This is my final answer.